was about, well, how would you say, like, yeah, you probably put it more eloquently than I could.
So I was thinking, it's coming where people have been applying for grad schools, undergraduate institutions, jobs. It's just that time of the year, right?
Yeah.
So I figured we'd do an episode on like the subfields of physics. It was actually requested by one of our listeners. See if I can find him on the thing. But in the meantime, so it's just basically we're going to talk about kind of the sub areas that you can actually get into in graduate school and also in maybe in industry, if we can touch on that as well. But I want to kind of focus it on graduate school first, because I feel like a lot of our followers, that might be relevant to them, especially even undergraduates. They just want to figure out what they want to do.
Yeah.
So we can kind of talk about like what actually happens.
Yeah.
In those respective fields, and then like what to expect, what you should maybe prepare to do.
Yeah.
All these things.
Yeah. And in physics, I think we're a little bit spoiled.
Yeah.
Because I mean, talking to other people, they just have a harder time getting into grad school, I think.
Who does?
Than we do, than physicists. Other fields.
Like which fields?
Humanities. It's because humanities and other stuff.
It's not as desired.
Funding is a lot less. Like in physics, there's funding. Like they need people to teach physics.
Yeah.
So TAs are
it's a lot
the cheapest
easier
way.
to. Well, the thing is, because also you kind of got to be crazy to go into physics.
Yeah, you got to be. People say you have to be a sadist.
Yeah.
You have to be like, or whatever it is, like. You have to enjoy pain.
A masochist.
Yeah.
The Caribbean Bookworm. Shout out to him for requesting the episode. Thank you, Caribbean Bookworm.
Thank you so much. We love taking topics like that, and this is up our alley. So
So I guess we can start off with our field one, condensed matter. So a lot of people who come into physics, they don't even know about this lesser known field.
Yeah.
I surely didn't when I came into physics. I was one of the typical plebe tier undergrads who would say, I'm gonna major in quantum physics.
Yeah. Well, I'm interested in quantum physics.
Yeah, I want to be a quantum physicist when I grow up.
Yeah.
But everybody knows who's a graduate student or who's in the field.
Yeah.
If you're saying that you want to be if you are saying that you want to do quantum physics, that means you really are just like starting off, or you're probably an undergraduate, because no one says that.
Yeah, no one says that. Yeah.
Like a lot of physics is quantum.
Yeah.
Condensed matter is quantum. High energy physics can be quantum. Nuclear physics can be quantum. All the physics can be quantum. So saying you're going to be a quantum physicist really doesn't mean much in the field.
No, not really.
That's how you know you're green.
Yeah. And I mean, like, you'd be doing, I don't know. I guess in condensed matter, you will be typically using quantum mechanics the most to answer some stuff, right?
But you could also say quantum field theory too. But you mean specifically quantum mechanics?
Yeah.
Okay.
Yeah.
Without the field theory stuff. Yeah, I guess so.
Yeah. I mean, unless you get to higher levels of the more new stuff actually accounts for. You need quantum field theory.
Yeah. So if you're distinguishing quantum field theory from quantum, then yes, you're right. I think condensed matter probably is one of the bigger ones. Also, people who are just coming up like to say they're going to do quantum computing stuff.
Oh, yeah.
And that's another one that kind of lies in the realm of condensed matter a lot.
Yeah, it does.
Right? So if you guys...
it's a I would say it's a subfield.
Yeah. Like there are plenty of condensed matter physicists who do quantum computing research.
Yeah.
For example, you can look up John Martinez in the Google group. That would be a prime example of a quantum computer researcher. And he's a leading edge guy too.
Yeah.
So that would be a good name to look up. And then, what's another one people love to say? Of course, astronomer.
Astronomer?
When you're coming in, they like to say, I want to be an astronomy major.
Oh, yeah. Astronomy's a weird one, though. But hold on. Before we get to astronomy, I want to say, like, condensed matter basically is the study of electrons, and even, like, sometimes, like, lasers, I guess, is a part of it, photons and stuff.
Yeah.
But it's typically... solid state.
We do a lot of optics stuff.
Yeah, we do.
So at least for condensed matter experimentalists, a lot of people also come into physics don't ever consider becoming experimentalist.
True.
90% of physicists coming in from undergraduate into undergraduate are saying they want to be a theoretical physicist.
Yeah.
So I'm sorry, guys, but most of you are not going to be theoretical physicists.
Yeah, they need actual mechanics instead of like just people pondering. It's a very rare day where you will be in the high castle of theory. You know what I'm saying? Like it's
not all of us can be Andrew Dodson. Shout out to Andrew.
Andrew, shout out Andrew. You busted your
he busted his ass, man.
Yeah, he busted his ass.
That's a hard feat to do.
Yeah, it is.
That means you got to be getting A's all day. You got to have a good rapport with the professors.
Mm-hmm.
You got to demonstrate a very high level of dedication. And you have to be able to perform.
True.
You have to be able to perform too.
Well.
That's really the big thing. Yeah. And not to say if you can't perform, because like me and Juan, we're not really good performers on exams. Notoriously, we're bad with it. And I'm probably a little bit worse than Juan is.
Sure,
but
there are a number of students that are just not great at exams, like that are really smart and intelligent. And
exactly. So don't beat yourself up and be like I'm a dummy and I can't ever do anything I want to do. It's like. You just may have a little bit tougher road. And I want to even discourage you from being a theoretical physicist. If you can somehow finagle your way in there, if you really have the passion to do it, I think you could get in there.
Yeah, I think some theory professors they'll especially in condensed matter, they're a little more lenient on they can let you be a theory student, but you'll have to definitely prove yourself if your grades aren't great. Yeah. Like you'll have to take on projects that you'll have to prove yourself a lot more.
Yeah. So to compensate for bad grades, you better be doing some extra. You got to show. You know what you can do.
Yeah.
That means like programming on your own time, like running simulations on your own time, or trying to solve some hard problems and prove that you can be in there. And then if you can demonstrate that to the professor you're interested in working with, then you might have a shot, right?
Yeah. Yeah.
Better than no shot. So don't be discouraged. That's true.
Do not be discouraged because a lot of professors will try you out.
Right.
Sometimes the limiter is literally the GPA. So But I mean, if that's all they care about, then you might want to reconsider working with them.
Yeah. Exactly. So just find a professor that's good for you. But anyway, back to condensed matter one. So we were saying that some of the things some of the techniques you actually use in condensed matter are like optics skills, right?
Yes.
What are some other techniques you can think of that you need to be a good condensed matter experimentalist? Let's go first.
Yeah, for a good experimentalist, you need to know basically how to do measurements. You need to know how to wire leads.
Yep.
On samples, and what I mean by samples is typically you'll have like some kind of thing, a crystal or something that you grew, or maybe even a device. Like a lot of us kind of work in devices and stuff, and literally when I say
silicon chips,
literally what I mean when I say devices is crystals on silicon chips, and then you wire them and stuff. So or flakes, it can be a few layers, it can be bulk, it can be more than a couple layers. So anyway, you have this sort of gradient of things, but you still nonetheless need to know how to wire leads. It takes surgical precision.
Yeah, some of these things are nanoscale, right?
Yeah.
So like some of the devices that I worked with, so I did some work with nano what do we call them now? Nano rods or something. I forget now what it's even called.
But nanorods.
So they were on the nanoscale, so that means I couldn't even see them. I had to actually use an SEM to be able to see what I was doing. Yeah. And then sometimes I would be able to use a microscope when it was a little bit bigger, micron level, or a few hundred nanometers.
Yeah.
But that means you have to be like a surgeon almost.
Yeah.
You need fine motor control to do these things, it's like you got to be very delicate with your touch.
Yeah.
So, maybe me and Juan may not look like the most delicate dudes, but
Terence is pretty good at it. Terence is pretty good.
I've gotten pretty decent at a nice touch.
I've seen him do woodworking. It's very precise.
You got to treat it like a lady.
For me, I will say I'm pretty good at laying down the wires, but like the second thing when you're laying down a wire is you use a lot of paste, a lot of silver paste or whatever. And it can get really messy.
It can get out of control.
And that's honestly where you will find the most trouble, because if you do not paste your wires on properly, your measurements will come out jacked up.
Yeah.
Because
you'll have crossing.
You have crossing.
Short circuiting. So it's like you get in trouble.
You get in trouble. So try. That's probably the biggest skill that you could get. Build yourself a little kit at home.
Right. If you can get like a microscope for Christmas or something, or
get a piece of yarn or a wire, very thin wire, and
There you go.
then just like put a little glue on it and then just kind of practice. I'm kidding. You don't have to do that, but whenever you get into a lab, just like you're expected to do a lot of that if you're an experimentalist.
right. Right.
That's gonna be in your wheelhouse.
Right.
The other thing is, depending, I guess you'll have to know how to use some kind of instrumentation. SEM is the most typical, I would say, for experimentalists.
Yeah.
Scanning electron microscope.
Of course, just to preface real quick, I don't want to mess the audience up. Like undergrads, you don't have to do all this yet.
No.
This is just things we're saying that you can. This is all the things that you're going to get into in graduate school.
Yeah,
With
more than
undergraduate,
likely.
you really don't even get that much lab experience typically.
No.
You can if you go into early, which I would suggest, but you don't always get that.
You're not expected to take on that stuff. Yeah,
Yeah.
for sure.
They expect more of a theoretical knowledge in undergraduate.
Yeah.
But anyway, this is like what you can expect.
Yeah.
So continuing on.
So SEM, scanning electron microscope. Honestly, I would advise for undergrads to get some kind of certification like that, like SEM, transmission electron
Did you
microscope.
get that?
Yeah.
Oh, that's cool.
Yeah. Yeah.
Damn.
It's
Okay.
it's a good way to get your foot in the door because you at least know how to do something and you show that this is the field you want to work in.
Damn, my man's certified.
Yeah. I was certified to use a scanning electron microscope. I got the training for
That's
that.
legit.
And yeah, just try to learn something that you'll be using a lot of the time and get comfortable with it. The SEM in particular, there's some that come with like X-ray systems that help you detect elemental composition and stuff. That's also nice for you to if you're going to be working in experimental condensed matter.
Right.
It's good to do that.
Yeah, so in condensed matter, basically, you get a lot of cool equipment under your belt.
Yeah, you do.
Like, I probably could use about 7 or 8 different machines that you cannot use anywhere else in life. Like, and especially because they're costly. They're $500,000, $1 million pieces of equipment that you just can't get access to unless you're in a research laboratory or maybe sometimes in industry as well. But yeah, it's pretty cool. I have such a knowledge now of these really fine esoteric pieces of machinery. So that's what you can kind of expect from condensed matter experimentalists. Let's kind of talk about a little bit of condensed matter theory. Juan, do you know much about what the theory guys do?
Yeah, I just see them sitting down all day. Nah, I'm just kidding. Nah, they honestly
surfing Reddit.
Surfing Reddit. No, I see a lot. Honestly, every time I walk into the theory floor, I always see the students sitting down and reading or programming.
Yep.
Yeah.
So pretty much that's going to be universal if you're a theorist.
Yeah.
You're reading and programming all day and writing.
And writing. Writing is, experimentalists reach the writing stage too. But I will say for the theorists, you're doing a lot more sitting down and coding. And
so if you're a person who likes to be in their mind palace, theory is the way to go for you.
I personally, I have to feel like I'm doing something. You know what I mean? Like,
yeah.
I can't just be sitting in my head all day because I'm like, this is so annoying. I need to get out of my head.
Right.
So,
you're like, this is dangerous.
I would be,
be a hyper introvert.
Man. Can you imagine?
Yeah.
Yeah.
That'd be bad.
For yourself, though, can you imagine that?
I think I could.
You could?
I think I
Okay.
could.
And like,
because I'm more predisposed to be an extrovert, right?
That's true, yeah.
So it's like I have to eventually go out.
Yeah. For me, no, it would be a bad idea.
Yeah.
It would be
You're
spiraling.
like, I don't need to talk to anyone, right?
I haven't talked to anybody in 2 weeks.
Right.
Yeah, man. No, but it's but yeah, you're experimentalists. You're expected to read and code and have that in your wheelhouse. You're more than likely, if you're doing condensed matter theory, you'll probably be doing some kind of like band diagram stuff. Band diagrams are huge. So learn how to use Win2K. I think it's WIN 2K. That's
What
like
is
one
that?
of those.
I don't even know.
That's
that
like
one.
a band diagram. Software program.
Okay.
Yeah.
Yeah, band diagrams and condensed matter are huge.
The cream of the crop.
Yeah, if you want to learn that as an experimentalist or a theorist,
Yeah.
cream of the crop.
Sorry,
that's all you like running back through your
my
mind.
bad. Yeah, I said the wrong phrase. You know what I'm saying?
No, cream of the crop is right.
Oh, it is?
Yeah, yeah.
Oh, okay, well, it's
you're
a cream
saying
of the
it's like
crop
top
software.
tier.
It is top tier, yeah.
Yeah, so if you do Venn diagram stuff, guys, that's really useful if you're a theorist or an experimentalist or whatever. So learn Venn diagrams if you like condensed matter, and your advisors will definitely be like, oh, shit.
Yeah.
This kid
knows
impressive.
his stuff.
Yeah.
No, for real. Advisors are definitely impressed whenever you come in with like some programming stuff like that, because there's a very short supply of students that will take on a task like this, and it's a good thing to have, and you become very useful. And you honestly, you barely need any real theory to do it.
Yeah.
It's
For
like
programming, you mean? Or?
Yeah. And then the professors are like, I would say, I mean, no disrespect to people who use this stuff and make legit band diagrams that are super complex, but to me, it's the equivalent of like your grandma asking you to plug in HDMI cable and turn on the TV. It's like, okay, I just put in a couple.
And they think you're a genius.
Yeah, just plug in a couple codes of line, and then most of the stuff is already kind of laid out for you online anyway. You just change the parameters here and there.
Right. So that's what you've been working with.
Yeah, I worked on it for some time, and then my advisor had me. He was just like, "Nah, just switch to something else." So
Gotcha. So I never really got good with band diagrams.
Yeah.
I'm a band diagram plebe.
Yeah, I'm having other kinds of bands, if you know, like the rapping kind.
Oh shit! Well,
I'm kidding. Yeah. I wish. Yeah, you're in a lab group meeting and you just put up like dollar bills with bands on there. These are my band diagrams.
Yeah, I love I made a trolling PowerPoint one time. Not full on troll, but it was like a silly PowerPoint.
Yeah, I don't
because basically I was working. I was working in we were doing homeworks during this time. This was like the first or second year of school.
Sure.
So we were always doing homework. So I was barely in the lab.
Yeah.
So my advisor was just like, "Can you just characterize the hot plate?" And I was like, "Fine." Because I needed to be next up on the group presentation list. So for the newbies out there, most groups. So you have a group of people that are in your, or I guess people are in your group.
Yeah.
So let's say if you work for an advisor, you'll have like 5, 6 maybe people in your group, and they present research, and in our group we presented every single week. So then one person would present their research every single week, and for mine, I did a presentation on a hot plate. And it was so like, it's like this really trivial thing. So I made it like all hyped up. I put like Brahms music on there, symphony music to make it all cool. And then, and I made like animations for it.
The trolling energy. I saw you doing this and I was like, oh my God. They're in for.
They liked it though.
I mean, I can imagine they liked it. They thought it was
One of
funny.
the students even wanted me to forward the PowerPoint to him. I was like, sure will.
Hilarious. Yeah, man. I mean, yeah. Oh, let me add this. So in theory, you will more than likely be there's less students typically in theory groups.
Oh yeah. In theory, you could be like 1 or 2
the only
max,
one.
maybe.
Yeah.
Like, because the thing is, theorists don't get really that big of funding, right? Because they don't need money. You can just do things on pencil and paper and a computer, and you're pretty set.
Yeah.
So you don't get money.
Yeah, you don't get money. You don't have equipment to maintain, none of that. So you're
so enjoy the
SOL.
broke life.
Yeah, enjoy.
Theorists.
Seriously, yeah. Get used to it. But you do have the perks of like basically working from anywhere.
Yeah.
Yeah.
I just like to take shots at theorists when I can. Anyway, let's move on one. So let's touch on the other one. So our field is condensed matter, so we're pretty in tune with it. But let's move on to the other ones.
You said astronomy was. Let's go back to astronomy. So astronomy was the other one, and astronomy is I hate to say it, the bastard child of physics, right?
Yeah, kind of. It's all the cool people go to astronomy, though.
Yeah, but that's emphasis on like the cool kind of bastard, like yeah. All the cool people do.
The bad boys and girls of physics.
Yeah, the bad boys and girls of physics go to astronomy because
right.
And they're typically like the hot girls and hot
hot guys and gals in astronomy. Yeah, for sure. They're more they're more socially
adept.
Adept. Yeah, exactly.
Yeah.
So yeah,
For
if you're a cool nerd, you probably want to go to astronomy.
For sure. Every Chad in physics I ever met is definitely in astronomy.
Yeah.
I even had a professor that he was an astronomy professor.
Yeah.
He was my like advisor, and I would go into his like meetings and we would talk. He would have like a 5-pound bag of whey protein, and he looked like he just finished. He's like, yeah, he was also from the UK.
Jacked.
He's also from the UK. He's like, I'll just finish doing push-ups and blah blah blah. He's like, I hope you don't mind me being sweaty. And then I'm just like, no, dude, it's all good. Like whatever. And like, fucking downing a protein shake. I was like, what a bro. What a Chad move. But yeah, astronomy guy.
Yeah.
Not a surprise. But yeah, every I will say the astronomy people are cool. So if you do find yourself not relating to a lot of the other physics cohort people, but you like physics and you like the stars and stuff, then astronomy is for you.
Yeah, we had an astronomy guy, one of my astronomy professors back in my undergrad.
Yeah.
He did, for his colloquium, he did a dance. He made everybody do a dance.
Oh, no. Made physicists do a dance.
Yeah, I was like, oh, boy. But it's actually good.
Do the
It
Macarena
worked out
or
somehow.
What did he make it?
It was like a solar system dance. And he was describing something with the dance. I forget what it was, but it was fine.
Okay, all right, if you say so.
It worked out somehow.
Okay, all right, man. I believe you.
But yeah, so astronomers, what you guys are going to be doing is basically what you probably think. Looking through telescopes, maybe not like actual, eye to glass, but you'll be using these giant telescopes in these cool ass locations like in Chile and California, Hawaii. So you guys get some badass vacations. So if you want to have some badass vacations, astronomy is the way to go.
Yeah, I mean, truthfully,
I'm always jealous of the astronomy people. I'm like, damn.
I envy them too. They get all the perks.
Yeah.
Well, I will say they do kind of get the lower end of like they're on the physicists in the departments typically look down on astronomy students.
Maybe so.
Because they're the Chads in the
exactly. Yeah.
How would you say? What's the female equivalent of a Chad? Let's not say anything offensive here.
Juan's gonna rope me in.
Yeah, I gotta tell Terence, remind him.
I don't know.
Whatever it is. Let's just say they're bros, and then the Kets, like you know what I mean. They're just yeah. And then the physics people in departments are already kind of like a tight knit group, and yeah, they're typically the astronomy people are definitely judged intellectually.
Yeah. Because I think they even have to. Well,
they have to take less physics.
They have to take
classes.
a little bit less physics. I mean, not that much though.
I don't think
they're
they have
still
to take
legit,
quantum,
straight up physicists.
They are, but I don't think they have to take like as much quantum, maybe.
Yeah, but in grad school, you're definitely gonna have to. So if you're in grad school for astronomy, I mean, you're gonna have to take quantum and all.
Yeah,
that stuff
you're basically
anyway.
gonna be doing what every other physics student is doing.
And actually, I think sometimes you might have more classes. Unfortunately,
maybe. I think in credit hours, probably.
Yeah, in undergraduate though, sometimes I think I think it really depends though, because I know some undergraduate institutions, you don't even have to take the physics GRE to get into astronomy graduate school programs. You have to do some other sidestepping routine.
Yeah.
But it all depends. Astronomers, you guys have some interesting routes you can go. And the only other thing is I'm not really sure the distinctions between theoretical and experimental astronomers. Do you know one?
I think theoretical astronomers, they probably just look at like more data sets from big collection centers.
Okay.
And then they extrapolate data or probably find some stuff in the data, use programming to find stuff that in theory should be there or could be there.
Now, was Hawking a astrophysicist?
Yeah.
Okay.
Yeah.
Let me just double check that.
Yeah.
So I guess if you're a theoretical astrophysicist, you'll be like a Hawking type.
Yeah.
Where you can.
Well, astrophysics is different, I think, than a pure astronomy. Because pure astronomy is like mapping the stars and stuff. Astrophysics,
but they use the terms interchangeably, right?
I think nowadays they do, but astrophysics is more of like studying how planets and stuff like that, or like celestial phenomena kind of happens, like using physics, like how planets form, how galaxies form, how black holes form, all that stuff.
Stars.
Stars.
Pretty much all the celestial objects.
Yeah.
Astrophysics
will take care of that. But like in terms of like movement of like how would you say mapping
dynamics of it?
planetary orbits and motion of celestial bodies, like that kind of stuff, is more of the astronomer's like for specialty, I should
I
say.
see.
Yeah.
And probably like the composition of celestial objects too, right?
Yeah, probably so. Yeah.
Okay.
Yeah, mapping and categorizing, I think, is the astronomer's job.
Yeah,
And
so
then astrophysicists, I think, do more of the characterizing of how those stars come to be. Maybe like, I don't know, trying to figure out, like, I don't know,
like how the Big Bang, like
Yeah.
the starts of Big Bang and stuff.
Sure.
Yeah, so I guess it makes sense. It's like the experimental astronomers are taking the data, looking at data and analyzing that kind of stuff, and then the theoretical astronomers are like trying to like understand like the cosmological constant or the formation of the universe and the formation of solar systems, more deeper questions like that.
Yeah, or the formation of certain planets in certain systems, and like
Yeah.
why they're emitting, this kind of light or whatever the hell. Yeah, they're. I mean, you have literally billions and maybe even trillions of data samples that you could look at. So it's like pick one.
So that's pretty much the crux of the astronomer realm.
Yeah.
So moving on, let's touch into the nuclear physicist realm.
Yeah.
So I'm a little bit less familiar with this one as well, but we know
Some
people and we know some stuff.
Well, some people consider that it's a branch of condensed matter, but I don't.
Oh, really?
Yeah.
Who considers it that?
I think in our department they might.
I guess it kind of makes sense. Because instead of electrons, it's like molecules and the other
Atoms,
particles like protons
stuff.
and neutrons and stuff.
Yeah.
So basically, guys, nuclear physics is basically the study of low energy particles. So it's distinguished from high energy physics, which is the study
Relativistic.
of relativistic particles, meaning they're moving at the speed of light or close to the speed of light. Sorry.
Yeah.
And yeah, that's pretty much the big distinction. So nuclear physics is like you will look at like I don't even know like
how like certain maybe like how certain phenomena happens in terms of like when you emit certain like
radiation?
Frequencies of radiation.
Okay.
Yeah, like and how that comes about.
It's like studying atoms, and I see why people would say that's kind of a subset or somewhat similar to condensed matter, because condensed matter guys, we'll study like atoms too in some sense.
Yeah.
But it will be like usually like related to electrons a lot of times.
Yeah.
But I worked in a lab where we studied like NMR type stuff, which is nuclear magnetic resonance, which is molecules.
Yeah.
So it's kind of
a wide, but it's a subset nonetheless of. It's nuclear, I would say. Is
these things get the lines kind of blur sometimes to where you don't really know for sure. But nuclear physicists, one distinction I guess is they use nuclear models a lot, which we don't really touch that often.
They probably use like Clebsch-Gordon stuff, figure out J numbers and L number, angular momentum numbers, total angular momentum, spin state stuff, and then they try to characterize the system. And yeah, I mean their preoccupation is more
the atom.
I guess characterizing the atom and radioactive compounds and stuff, and then
like they will be concerned with like gluons.
Sure.
They'll be concerned with things like neutrons. They use particle accelerators, for instance, in experiment. Where condensed matter physicists, I don't know if I've ever seen a condensed matter physicist use a particle accelerator.
No. Well, in the sense that in the solid state kind of physics branch, electron stuff,
Yeah, so that's kind of the distinction between the nuclear physicists. They're like just shy of being the same as a high energy physicist almost.
True. They're just not as high energy.
Yeah. That's really the biggest distinction. So high energy physics, they just crank up the energy scales, and they'll be the guys and gals you'll see at the LHC.
Nuclear physicists at the LHC.
Yeah. There will be things I think Fermilab, maybe even Brookhaven. So they have the high energy scales where they're accelerating particles super fast and then colliding them at high energy.
And you're looking at more fundamental particles, I guess, at those regimes.
Yeah, right? You're trying to figure out like standard model stuff, like new particles, supersymmetry, things like, of course, the Higgs boson is the prime example. Yeah, so you're looking for new physics pretty much
Yeah.
by testing the bleeding edges of energy scales.
Mhm. Well, I will say, like, there's a difference between nuclear theory and nuclear experimental too, as there is in
Yeah.
high energy, which is all, I guess, also
You
nuclear.
got a
too.
good characterization?
Yeah, nuclear experimentalists, like, you will more than likely be making a lot of your equipment yourself, detectors,
Pretty much a
instrumentation.
constant in experimental stuff. You're going to be making all
Yeah.
your own stuff.
Yeah, which
pretty
is a
much.
very valued skill that if you're worried about getting a job, you probably shouldn't,
Yeah.
because you will have a lot of technical skills.
Yeah.
Yeah, man.
Experimentals actually get jobs. Sorry, theorists.
Well, theorists do get jobs, but they get jobs as like data scientists more than likely.
Yeah. Data analysis and
yeah,
that kind of stuff.
Yeah,
Finance.
yeah,
Yeah.
yeah. But the experimentalists, you will get you will get those kind of jobs because especially in nuclear, you'll be building a lot of your instrumentation from scratch. Like your advisors, it's the cheapest way to do things a lot of the time. You'll build your own detectors if you want to detect certain things. You'll be tasked, especially if you're doing your own project from start to finish for your thesis. Yeah, you'll sometimes. Yeah, I think we know a guy. We know a guy that literally had to build his own like kind of detector and
Yeah.
install it.
It's pretty
and-
cool.
Yeah, it is cool. It's very cool stuff, and I mean, yeah. And then the theory students, I think they collect data from big labs like Fermi Lab, and
we'll try to extrapolate kind of qualitative knowledge from that, write papers on that.
True. Or see things that maybe they hypothesize or something.
Right.
Or
Like the
look for
person who
things that they
discovered
hypothesize.
neutrino oscillations, for example, would be a high energy theorist.
Yeah.
You know, they tried to understand why neutrinos, why they change mass or energy or something.
True. Yeah.
And they explained that using theory,
Yeah.
of neutrino oscillations.
Yeah. And that's and that's pretty much high energy theory. And high energy experimentalists would be doing something similar to what the nuclear experimentalists people do, which is
The people in the LHC are the ones who are, putting those giant magnets
Yeah.
inside the facilities and, well, I guess maybe those might be the construction workers actually.
Yeah.
Because the LHC is such a gigantic project. It's like you got technicians, construction workers, and physicists all
Engineers,
building
yeah.
stuff, right? The physicists will probably be more in the realm of like wiring up all the sensors for data collection and things.
Yes.
And then putting all that into a server and having all that data allocated in one location.
Well, there's certainly experimentalists doing building the diagrammatic, I guess, the diagrams of or blueprints of some of this instrumentation because you're going to be deciding what is being measured and how to measure it, and that's the experimentalist job. The theorist job, I think, is just coming up. Usually, from my experience, like if I'm working with theorists, they kind of just they say what they want to measure, and the experimentalist figures out how to do it.
Yeah.
If it's possible.
It's a nice little synergy
Yeah.
where you're like, I want to see this, and then
Then you sit down and think about how to do it, how to measure it. Yeah.
Right.
And that's really the genius of it if you can figure out a way to do that. And so I mean, the cool thing about being a high energy physicist too is that you will get to go to Switzerland and France more than likely.
Right.
At some point in your PhD career, you will get a paid trip to
Right. So if you're
to the Swiss Alps.
if you're a American swine like us,
Yeah.
and you want to go on some cool European vacations,
on
high
the
energy
dime
physics.
on the dime of your advisor.
Yeah, exactly.
Yeah. It's
expenses paid. Do you get per diem for that too, or no?
I think they do, man.
Okay.
I asked those people, and I'm like, I'm
Bastards.
so jealous. So jealous of you all.
Yeah.
Like, I wish I could enjoy high energy physics, but I don't know, because that's such a cool gig. Like,
Yeah.
going to Switzerland, just living there in Europe,
Right.
and then getting to come back.
And honestly, one of the things that really sealed the deal for me, to be honest, with being a physicist, was the conferences.
Yeah.
we had free beer at a conference, and I was
Yeah.
like,
Amazing.
"It's a wrap." I'm a physicist, y'all.
Yeah. Yeah, he went on Facebook and was like, "It's Facebook official now. I'm a physicist."
Yeah.
Put it on there. Yeah, man. I envy you all, high energy people, for getting to do that. And
Right.
and I think you typically end up landing on good jobs. I think that's regarded as an impressive feat. I think for any industry.
Yeah, for
They'll
sure.
more than likely just be like, this guy worked at CERN.
Yeah, yeah.
Or this.
It's a good resume
Yeah.
piece.
Yeah,
we'll
for
say.
sure. I think regardless of whatever you do, but
Right.
yeah. What else? So we have high energy, astrophysics, condensed matter,
Nuclear, condensed matter. I think that's all of them.
optics stuff.
Optics we can talk about. Yeah.
Well, optics is condensed matter, but yeah.
Yeah,
like,
but optics sometimes is like this weird one that gets sometimes gets its own spotlight.
it's true.
Like I went to a school where optics got its own kind of spotlight.
Yeah.
But not always. It just
Yeah.
depends on the institution you're at. But optics can sometimes be so, I guess, has so much, so many things you can do in optics that sometimes people will actually separate it out from the other ones.
True.
And we're familiar with some optical stuff experimentally because we're condensed matter physicists, so we have done many experiments with that. And of course, the classic things you do with optics would be like Raman spectroscopy or Rayleigh scattering. You'll work with frequency doublers and triplers, half-wave plates, quarter-wave plates. All these things are like special pieces of equipment that you can use to actually probe different materials and whatnot.
Yeah, you're nevertheless using these instruments to characterize samples and stuff, devices even.
Yeah, so optics is like almost its own field, right? When you're getting into condensed matter, you're going to become an expert in optics if you're or condensed matter experimentalist.
Yeah, I mean, a lot of the time you'll be building a lot of your own like laser setups.
Yeah.
And just tweaking all that and making sure that everything you basically become a master of this particular setup or whatever technique you're using to measure your stuff. But I'm trying to think of what else. I guess optics people also help with device characterization as well. Like if they want to measure like how efficient something is at absorbing light.
And there's a ton of optic techniques that are really useful for experimental stuff too. Like I wasn't one. Frog is the one I think maybe got a Nobel Prize or something. Kind of within the last few decades. You don't know it? Okay. There's also like chirp pulse amplification. There's things like magneto-optic Kerr effect for magnetic stuff. There's a bunch of different optical techniques that are extremely useful. That people use. Yeah,
for sure. I mean, ARPIS is used to characterize band diagram stuff. It's angle resolved photo emission spectroscopy, I think.
Okay.
But yeah, there's a lot of good techniques that that come with optics. But all the experimental optics. I don't know if I've ever heard of a theoretical optics person.
I don't think it exists.
I don't think it exists
because people already are reluctant to like make optics a thing as it is, right? So
true.
I think they just want to have it as it's to help experimentalists do better experiments.
Yeah, characterize stuff. Yeah.
So it's almost like an afterthought just to help experimental physics.
Another little subset nook of condensed matter. Yeah, for sure.
Actually, that makes me think of another kind of thing that's related. Sometimes departments have measurement people as well.
What do you mean?
So specifically, usually condensed matter, once again.
True.
People who specifically are looking for ways to improve measurement.
True.
So like improve kilogram standards, improve like precision measurements of, let's say, of like Planck's constant or something.
Yeah.
Measurement people are very important and extremely critical because those are the ones that are confirming the universal constants down to extremely high precisions.
They improve instrumentation and they also, in terms of accuracy and precision, like you're saying.
Yeah.
And then also make sure that there's scientists that understand how this instrumentation works. And those people will typically end up working for instrumentation labs or industry like quantum design, like designing maybe new ways to measure stuff.
And NIST would be like the granddaddy of all the measurement facilities, right?
Yeah. NIST, National Institute of Science and Technology, for those of you that don't know. It's an American institution, but they work on standards.
They're the ones who made this part of people who made the decision to like redefine the kilogram recently.
Yeah.
Well, recently within the last few years. But yeah, so that's kind of I guess you could say that's kind of a subfield of condensed matter. So if you get into condensed matter and you want to do measurement, that would be in that realm, I would say, would be the best way to go.
For sure. I forgot to say, lasers, the Nobel Prize was given out to a laser guy.
Oh, recently?
No, like a while back, but it was because they were using laser cooling, or this team was using...
Oh, right. That whole thing is still kind of weird to me. Like, you can actually cool things down to millikelvin temperatures using lasers, which you would kind of think...
I think you emit radiation, and then you kind of cool the body, or the molecules or whatever.
Right, it's getting the particle to radiate by stimulating it with lasers. But it's kind of counterintuitive because, you think... Because we're, since we're macro scale beings, we're thinking it would heat it up somehow.
Yeah, because you're bombarding it with light. It's like,
But it actually causes it to radiate heat away, so you can make supremely cold temperatures with lasers.
Yeah, and that's how they did it. They got super cold atoms with lasers. Yeah, you could do cool stuff like that with optics, and you wouldn't know unless you were an optics person that this was a thing you could do. Or think about doing.
Right.
Yeah.
So optics is kind of a rife area.
Yeah.
But if you have no optics, if you're interested in optics and you have no optics subdivision in your school, condensed matter is where you would probably
more
go
than
towards.
likely. Optics has now been rebranded. There's so many rebrands in physics that you kind of have to especially in condensed matter, that you have to kind of wrap your head around a lot. Like it used to be solid state physics, now it's condensed matter physics. Optics is now a part of some acronym called, starts with the MO, molecular optics and something.
I don't know. No idea.
I mean, give me something. Give me something.
Yes. What?
Because I'm looking up the
Sure. So I'm trying to think of some more subfields that are really cool that maybe people would be interested in. I guess if you want to get heavy into computation, let's say if you're a badass programmer, you just love programming, but you also love physics. Computational physics is also...
I got it.
Yeah, good.
AMO, atomic, molecular, and optical physics.
I never heard of that.
Yeah, it's a study of matter.
AMO.
AMO. Yeah. It's a study of matter, and light matter interactions on the scale of one or few atoms and energy scales around several electron volts. AMO theory includes classical, semi-classical, and quantum treatments. But yeah,
okay.
Like I'm saying, a lot of this stuff is rebranded over time. You kind of you have to keep up. But computational physics, you're right. It's totally...
Yeah, so computational physics can almost go anywhere, really. But usually you would want to sway yourself towards heavily computational areas. So that would be areas where they have a lot of particle systems, or maybe some higher level things that are closer to chemistry or biology.
Yeah.
Maybe even, but you can go so many directions, even astronomy, condensed matter. So computational physics is like being able to be a person who can code well, but also can know how to utilize using supercomputers and clusters and things like that to make these heavy computations. Diagonalizing 1 million by 1 million matrices.
Optimizing code to do that. Yeah, for sure.
So that can go in a lot of different. You can do that in a lot of different areas of physics. It would just be how heavy of a programmer you are. Of course, you can also lean towards machine learning and things like that. This is almost going into the bleeding edge of what's happening now. Yeah. Because I don't even know if machine learning has really been implemented well in most physics departments, but it's definitely something I could see on the horizon for sure.
Yeah, for sure.
Because also, physicists are have already been getting heavily into Bayesian probability and stuff, which hasn't been a thing really until kind of recently as well.
Yeah.
So if you're interested in computing and probability and that kind of stuff, machine learning, computational physics might be something to consider. And you can pretty much go in any realm of physics, but you just need to have a more heavy concentration on the programming, computational aspects of physics.
Yeah, you can do like you mentioned it briefly, but biophysics is also an avenue.
Yeah.
That's being heavily studied and has a lot of applications, especially into the medical industry.
Right.
Biophysicists are being sought after because they're the people that are going to be helping
Biologists.
in characterizing like making drugs essentially.
Money.
And that's a huge moneymaker.
Anywhere with money is a good place to go.
Yeah, you're more well equipped to help, I think, than maybe. It's a different approach than what chemists do. Chemists do a lot more like it's a different approach, but nevertheless, your end goal is the same. But physicists probably use more mathematically analytical tools.
Yeah, you're a little bit of a god if you're a biophysicist as well, because if you're bringing all your physics techniques, and you're probably going to be in a realm more with a lot of biologists.
Yeah.
So
or chemists.
You kind of differentiate yourself as this very inexpendable person.
Yeah.
So the biophysicists that we know, like they have a very good place in their group, and they're very relied upon heavily. Yeah. So yeah, if you wanna make sure you have a good secure spot in life, biophysics is definitely a very good one to pivot towards.
For sure. And yeah, you will definitely land on your feet with those kinds of things. It's a hard field though. I will say it's difficult.
It is, because it's just so computationally heavy, right? Yeah. It's not like physics where you can just always rely on the electron always being, the same charge, the same mass. Like biology is like there's all kinds of shit going on. It's complicated. It's like humans, you know.
Especially if you increase the number of atoms and stuff. Yeah. I mean, it took Google's team for some amount of time to try to map out the viral 90% or something of the viral what is it?
Of the
protein.
Coronavirus?
Yeah.
Okay.
90%, and it took a huge team, but a physics student has to do this.
Oh, you're talking about AlphaFold.
Yeah, AlphaFold. Yeah, well, whatever. Yeah. It wasn't Corona, right?
No, it wasn't Corona. It was just it was a weird protein. Yeah. So these kind of things
biophysicists will basically do that.
Yeah, you can do that, and there's other things you can do as well.
Yeah.
Mathematically, but biophysics is pretty cool. And I'm sure you can even spawn towards like medical stuff too, because
medical physics.
Yeah, like I don't know if that's even a thing, but I'm sure it is, because it's like
instrumentation for medical industry.
Yeah. Because there's a lot of physics that has to go into biology of
measuring tissue and stuff like that.
Humans, because like the heart pumps using what is it, electromagnetic pulses. The brain is all pulses. Once again, electromagnetic pulses as well. And then even things like arteries and things. Like arteries, I'm pretty sure the mathematics is the same math that you use for currents.
That's hilarious.
Or at least if it's not exactly the same, it's similar, at least maybe on the fundamental level.
Yeah.
But yeah, so there's so much physics that goes into medicine as well. You could probably pivot towards medicine or medical school as well using physics. I think even physicists score the highest on the MCAT, I want to say.
Yeah, probably. You're combining two personalities into one. You're combining med students and a physicist.
Right.
God
That's a deadly combo. Yeah.
God help us all.
Yeah, it's a scary sight.
It is. I mean, med students are already on edge.
Arrogance beyond beyond any mortal man.
Yeah. It would just be, yeah, man. And anytime I met somebody that was a type A personality, they were like, I'm going to med school. And I'd be like, okay, I'm not, but they're that combined with the physicist, that would be
that's a lethal ego. Yeah. But yeah, so those are some cool things you can do. Anything else you can think of, Juan?
Let's go through the list again. We have,
I got another one.
Sure.
I didn't mean to interrupt you, but it just came to me. Teaching.
Oh yeah,
education.
Yeah,
education.
Yeah.
That's a great one. All the nicest, like most approachable people I've known
our
physics education. Yeah.
Oh yeah, 100%.
And like have nice balanced lives with families and wives and kids, and
that's me, bro. I need that. That would be, honestly, if condensed matter physics didn't work, I'd be like, physics education.
Yeah.
Could be nice.
Yeah. If you're like a person who likes balance in life and actually likes to have family and and like
some semblance of normalcy, for sure, yeah.
Education physics people have always been those kinds of people. And you do really cool stuff too, because they'll do like you have to go a pretty far track in physics, so it's not like you're a slouch and you don't know physics. You pivot later on to more heavily on what students are or how to help students learn, what techniques you can do to help students learn physics better.
Yeah.
You can also do studies like how students score on particular physics questions and things. And, physics as education is very useful. And you can go into a lot of different things. Like you can be high school teacher. You can also be professor many times, lecturers. And you have a lot of opportunities as a physics educator, and even you can do research in it too.
Yeah, you can.
So it's a very good area to go into.
Yeah. I mean, I would do it probably. I mean,
yeah, it's a good one.
Yeah, just because physics education is so like, it's interesting to both of us because I think you and I both get frustrated at the complications that some
seems like it's overcomplicated.
Exactly. Yeah, a lot of the time we're like frustrated with how simple it can be, and it's not.
Right. So if you're a physics education, I've noticed also, the physics education people are way better at explaining and understanding physics and communicating it. Yeah. Like, for example, a physics educator would be like Veritasium.
Yeah, Veritasium.
Like, and you see his channel is like top tier in explaining stuff. So like, a lot of the physics education people really know their shit and how to actually convey it in a meaningful and understandable way.
Yeah.
So that's a very good field to go into.
And a skill. It's a great skill too.
Yeah.
You
have many job opportunities in that.
You do, especially in like the entertainment industry or things like that, just dissecting like I think a lot of physicists end up also do scientific writing, like but you can do scientific writing with a bachelor's degree.
I've seen physics educators who go into actually making articles too.
Yeah.
Is that what you meant?
Yeah. But bachelor's people with bachelor's in physics can technically go write for Science or whoever, Quanta, any of these scientific magazines, and like write articles for them, and they'll.
Yeah, and actually, you can even just get a physics bachelor. Let's say if you do a bachelor and get it specialized in physics education, you can immediately go right to teaching high school.
Yeah, like that too. Yeah.
No PhD, no masters. You just go immediately into teaching high school.
Yeah.
And you're super sought after.
Yeah.
If you got a physics degree with an education combination, and if you want to do high school teaching, you're like guaranteed a job everywhere.
Yeah, anywhere. And like I guess if you do want to teach at higher levels, like for instance, if you do have a master's degree, you can teach at a college. At a community college or a college, but typically a college, you will be like assistant professor. Is it assistant professor?
Yeah,
it's like a lecturer.
So.
It's
lecturer,
like a special
assistant
title.
Professor. Yeah,
it's like a special title, but you will never reach professorship.
Yeah,
like
lecturers get shit on, but they're so vital to the infrastructure. And and there's nothing wrong with it. You make a pretty good salary too.
Yeah,
it's a solid gig. I think you just won't get as much respect.
And the faculty, no. But I mean, with the masters, you could.
The students will respect you, but the faculty will be like, "Oh, you're bullshit."
Lesser than.
Yeah. And you get no tenureship as a lecturer.
You get no tenureship. There's no hope of you getting any kind of benefits that the faculty do. Yeah. But then again, here are the trade-offs. So I will say the trade-offs if you want to be an academic, a professional academic, you pretty much have to resign your life to basically living in one place for the rest of your life if you want to seek tenureship at a university. And
tenureship is brutal too, man.
Yeah.
It's a process.
And you thought academic hazing was a problem when you were a grad student.
Yeah. This is the thing that they don't tell you. Academic hazing never ends. If the higher you go, like you think the PhD, I'm done.
Yeah.
No, you're still going. If you want to go into academia, you're still getting hazed. It's a continuous, endless process.
Yeah. Yeah, it is. There's a masochism in there. It's
By the time you're like 60, maybe you'll stop getting hazed because now you've reached tenure. But Jesus, man, it's like.
And now they've whipped you so badly that they're feeling bad for you because you're old.
Yeah.
And you're hunched over and you're like,
you got white hair. You're just broken as a human. You're like, finally, I can start living my life.
Yeah. Finally, I can start flying planes like I've wanted to at 20 years old.
Yeah. So I would definitely say, guys. This is a thing you got to learn in life. Like, you can reach endless heights. Yeah. Doing a lot of just keep progressing up the ladder. But there are sacrifices to be made. Like, It's like, this is what I've noticed. It's like things are not really hard any harder the higher up you go.
Yeah.
It's just that you're going to have to start making sacrifices on what you want in life.
Oh, yeah, exactly.
That's really the key. It's like the hardness isn't the thing. Like,
Yeah.
it's all about just how much do you really want to do X?
Yeah.
You know,
How much are you willing to give up?
yeah. How much are you willing to give up? Do you want to maybe have no family? Do you maybe want to have, so
No sanity?
yeah. So, and sometimes you can swing, you can have your cake and eat it too, but it means you have to be working even that much harder. So it's like,
for sure.
yeah, you just have to know what you want in life. And of course, undergraduate and school, these are the places to find this stuff out.
Yeah.
So,
I guess, yeah.
Hopefully we can elucidate you guys on the down low, like what's really the story.
Yeah, for sure. And I mean, I will say, like, I just want to say, like, it's very hard to get an academic job, and you will more than likely be begging instead of choosing.
Yes, and you'll be doing multiple postdocs.
So that means, nowadays it averages like 2 or 3.
Yeah. So that means postdoc is basically after you get your PhD, you're gonna have to work in another random lab
for 2 years
and just sit waiting, hoping that an academic position will open up.
Well, not now hoping and waiting. You're expected to do research and pump out.
But I'm saying you're really like there to try to build up your research and go to an academic
CV,
position.
Yeah.
But you're still getting paid in peanuts. Then you might get a better salary than a graduate student.
For sure, you will be. At least
it's livable. At least,
at least it's livable. It's usually double what a grad student makes.
Yeah, but if you have a wife and kids, you're pretty much fucked. So don't do that if you have a wife and kids, because it's a measly salary.
Your work-life balance is also still kind of shit.
Yeah.
Sorry to say.
Yeah.
But yeah,
and then you might have to do 2 or 3 of those, and maybe get an academic position at a random junior college.
Yeah, you'll be traveling extensively. It's a brutal process.
Yeah,
and you like Terence is saying, they make you jump through so many hoops, and at the end, the professors are so whittled away.
Your ego's so defeated.
Yeah, they're so sour and they hate everybody and everything.
Right, they're like, this is probably why professors just want everybody to feel their pain.
No, really. I mean, I had a friend of mine that was we were in bachelor's, doing our bachelor's of physics together, and he was just like, this sucks so bad. And he's like, you know what? If I ever get my PhD, I'm gonna do the same thing. I'm like, why? Why would you?
I heard somebody say the same shit too. I'm like, why would you want? I'm like, the pain.
Yeah,
you're supposed to break the cycle.
Exactly,
right?
Man. Like, why would you want to do this shit? This is so bad. Like,
it's like joining the dark side.
It is. I'm like, I'm part of the good side.
Right.
That's the problem. I think all the good
Jedis get out early.
Yeah, I think all the Jedi people leave. They're just like, there's no way we're gonna keep this system going.
It's what they say. You either die innocent or live long enough to see yourself become the villain.
Yeah, it's honestly true. Like, I think in academia that's so true. But yeah, I mean, like that. But I'm saying that's not to say like don't feel defeated if you want to teach, or even get a master's and then teach at the community college level, or college level. And even lecturer / assistant professor level, like,
right, and that's a pretty good job. Like, you can get paid pretty well.
It's a good gig. I mean, if you
may
like
not
to
get
teach,
as much as the major universities, but you'll get pretty.
You're not going to be
solid
tenured.
Salary. Yeah, exactly.
But I have we know some good professors that don't even get tenureship. That that just almost deserve it.
Yeah,
with how good they are, and it's like, wow.
Yeah, but that's the thing is, like, it's these arbitrary metrics and things, right?
Yeah.
So
you have to remember that the politics in the community of the department is also huge, and
that's actually a very important lesson too. One, I think, for your undergraduates and people, even graduate students out there, guys. I hate to break it to you, but politics never ends.
Yeah,
it doesn't matter where you're going to be. Scientists are not these arbiters of truth, who sit on the throne of justice and morality. It's like,
it's not
politics will be there forever.
Yeah, it's not purely merit based either.
No. It's definitely not a meritocracy.
It's usually about who you know and who likes you.
Yeah.
Yeah.
Like, you can be this badass student who's getting A's and slaying, destroying.
Yeah.
But, if you're like an asshole and nobody likes you, then that's not going to be good for your job prospects and your future in research.
Yeah.
And you always need letters of recommendation in life.
Yeah.
You think it might be just for school, undergraduate, or graduate. I hate to break it to you, but it also happens for jobs too in industry. Like, letters of rec are forever.
Yeah, for sure. So be sure to try not to burn any bridges. I've seen that happen a couple of times.
Unless it's a really Unless it's really tempting.
Don't take the nuclear option, whatever you do. don't take
Unless they're straight up dicks.
Yeah, don't take the nuclear option. I've seen it happen, and I was CC'd in some huge email from some guy like just literally going nuclear. He'd be
just went off.
He just went off. He's like, PhD fucking sucks, and he was just like, it was bad.
And they're like, blacklist.
Yeah, man. I was like, damn, dude, you really
not the way to go. Not the way to go.
Even if the best way to do it, if you leave anywhere, is to just
punch him.
Is to just just be like, thank you for the opportunity, blah blah blah. Be graceful about it, and just
Yeah,
and
things in writing are also very good too.
Yeah,
it's proof.
Yeah, yeah, true. But yeah, I think did we hit all the fields? I think we did, right?
I think we did. What's our time? Oh, we're at 103.
Yeah,
when I need to wrap it up.
Yeah.
Damn, that was pretty easy, actually.
Yeah, that was. Are there any other fields, I guess?
Any other subfields?
Besides,
I guess you could say
physics?
science popularizer, which is kind of the route we're going right now with the whole podcast.
True.
Except we're not really. We would never be a popular. I don't think, at least with this format.
Yeah.
We got too much cursing, too much bullshitting, too silly. We'd have to Disney-fy ourselves up a little bit more.
Disney-fy ourselves? Yeah, there's a lot more for science communicators. It's a lot more. It's more of the forte of or subset of the science educating.
Yeah.
I guess subfield,
like the Veritasium, Grant Sanderson.
Yeah, but there's a lot of production value that goes into like making these kinds of videos. Like podcasting is more of a discussion, and it takes a lot more time for the listener to to invest as opposed to a 10-minute video, which is what you usually see.
But I think if we really wanted to, we could go the science popularizer track, but it'd be very different from the normal.
Oh, for sure.
But we would have to clean ourselves up so fucking much.
Yeah, it's possible.
Or we'd have to be so big that we'd be undeniable, which would be pretty hard. But it's possible for sure.
It is possible, yeah.
Yeah.
But I mean, like Kevin Garnett says,
but then when people see that we're talking about,
well, this is as long as they don't go to our Patreon episodes.
Yeah, we're talking about all kinds of crazy shit that they're going to be like, canceled.
No, we wouldn't be canceled. They would just be like, wow, these guys are really just...
Yeah, they just wouldn't put us on.
No, we're referencing our Patreon episodes, but we get very silly on the Patreon episodes.
But we've said even things on the normal episodes.
Yeah, no, we don't say anything heinous.
Nothing heinous, but I'm saying like to be in the public, you have to be very clean.
Oh, true. As a scientist,
especially as a scientist, there's a standard that's like so squeaky clean, it's very unable to be matched.
Think about it. It's
you
very conservative.
You can't do it if you're any kind of like if you're any kind of liberal type person. Like if you've been cursed, that's already pretty much borderline too much in the science. Popularizer
and that's
realm.
something that bothers me about science, how puritanical it is in that way, in that sense, like very clean and.
Yeah, it's kind of annoying to me. It's like, okay, guys, it's like the days of old, like how they did with like football and sports and like basketball. It's like I'm hoping like guys like us and like even like Andrew Dodson and Flammable Maths. Like I hope we can kind of break that mold a little bit. You know, although I think Flammable Maths and Andrew, they're more cleaner maybe than us.
Yeah.
But still, like they're like cooler,
more casual,
more casual.
Yeah.
Not like this fucking buttoned up.
No, we're not taking shots at anybody. We're not taking shots at anybody.
Yeah, if that's your style, then I say be yourself, of course. But that's not our style.
And one of these, like one of the NASA scientists that did a launch a couple years ago. He had like a mohawk and like had tattoos.
Yeah.
And he got publicity just because he was like a scientist who had some semblance of self-expression.
Yeah.
It was just like they were so shocked. They were like, oh my goodness. But it's like that kind of like, I'm pretty sure that person got a bunch of looks and stuff like that. And,
he probably had a. And people won't take you seriously, right? Like an advisor will be like, "Oh, this kid's just like, they're not serious. They're not a serious physicist. They're not a serious astrophysicist, or what is it? Aerospace engineer." So you'll get shit, but of course, that's just the process of obstacles in life.
Yeah.
You have to commit to what you want to do.
Yeah.
And eventually, once you get on the other side and people see you got the PhD, you got the respect, you got the cred, then it's like you're undeniable.
Yeah. So
it's all good.
Keep pushing on, folks. If you're one of these types, don't let them break you.
Yeah.
And
retain your personality.
Retain your personality. Yes, that's really the lesson here. And but I guess that would be it. I feel like we're missing something, man.
A field?
Yeah,
we probably are. In the comments, leave it for us because we have a max time limit here. But leave it in the comments. What other fields, subfields of physics?
What did we miss? What did we miss? Let us know. And I think that's it, right?
That's it.
Yeah.
So guys, like, share, comment, subscribe. Once again, check out Eigenbros.com. Check out Eigenbros on Twitter, Eigenbros Instagram, Eigenbros2 on TikTok. And thank you once again, Patreon subscribers. If you guys are interested, check us out at Patreon, and you'll get a 30-minute podcast every week, guaranteed.
All righty. All right, folks. Thank you, and welcome to a new year, I guess.
Welcome.